Welcome back, my friends. We are looking at enhancing the card game war project from the WiByte Python curriculum available at www.wibyte.in. We have been looking at how we can enhance the toss. In fact, we'll go a little bit further in that direction. Previously, we have seen cases where both the players pick up one card. Now we decide the winner based on that one card, either its number or its suit or a combination of both of those. But here, let's say we take it further a few more steps and we say, okay, look, instead of one card, let's say we have both players picking up multiple cards. For example, player one can pick up, say, a few cards from, let's say, first 26 cards, and likewise, player two can pick up, let's say, a few cards from the next 26 card. Now, remember, I do this because this gives me a non-overlapping set of cards, which is easier for me to handle. And this is also fair and totally luck based. Now, once having done this, we look at some features of this card. For example, we could ask ourselves, well, are they from the same suit? What do the two numbers add up to? Or do they form any pattern? In fact, there can be many such examples, that you can do. However, just like before, we will have to put this in a while loop because we may have to do it again. Now, before I move on, I just want to highlight this very important point, which must be understood, that in fact the ideas that we are using here for toss can very well be applied to the game itself. Just imagine in the war game, let's say instead of picking up one card, the player picks up multiple cards, say maybe two cards or three cards, and the computer picks up multiple cards, and then we use some metric, perhaps the sum of the cards, perhaps the difference of the cards, and so on, to, let's say, create the winner. Yeah, now we will actually see this later, but at this point I just want to highlight the ideas are in fact very highly applicable. In this video, however, we will look at two examples. First, we will look at the sum of two cards where we'll ignore the suit. The first problem that I have is that now, remember, I need to pick up more than one cards. I'm going to use random.choices, not random.choice, because random.choices gives me, in this case, let's say two cards, gives me this PC toss and CC toss in a list of, say, two elements. Now, there are actually more parameters I can tweak in this random.choices, but I want to keep the whole thing fair. So it's equally likely to pick up any two cards from this list of 26. And that's what I do. Now, once having done this, remember my goal here is to figure out, ignore the suit, just see which two cards are summing up to a bigger number. This is quite easy. I can look at PC toss 0, 1. Now, this has to be clearly understood. I'm looking at always a second character, but I look at the first element of PC toss, second element of PC toss, because remember now PC toss itself is a list. I add the number of both the cards for the player and the computer, and accordingly I decide who wins. First, let's just do this before we go on to the second example. So like I said, I come into my code here. I say, well, pick me two cards, not one. So I say CC toss and PC toss both are, let's say, going to be two cards. For that purpose, I specify, say, 2. And again, I say k equals 2. This will give me a list of two items for both PC toss and CC toss. Now here I'm going to, again, I'll comment this out. Remember, my goal here is to figure out the sum of the two cards in the list PC toss 0. So I say, well, look, if say cards dot index, again, I must index in the list cards, PC toss, say 0, 1. Now don't get confused by this. Basically it's saying, look, PC toss itself is a list. Hence, I look at the first item of that, which is PC toss 0. Now, that is a string, and hence I look at the second character of that string. So that's how it's PC toss 0, 1. Cards.index PC toss 0, 1. Plus, let's say cards.index, say PC toss, say 1. Second item of the PC toss. And again, I must look at 1. If this is, let's say, more than, same thing for the computer card. So if I just say this, well, if this happens, if this is, let's say, more than, in this case, CC toss 0, and here again it should be CC toss. So if this happens, well, then my player wins. I need a colon over here. On the other hand, so let me again comment this out first. On the other hand, if the reverse situation happens, which means that my player has got a smaller sum of cards. Notice here the suits are being ignored. I'm just finding some of these cards. If the player is smaller, then, well, the computer wins. Now, when I run this code, I see that my player has picked up spades of 8 and spades of, so 8 of spades and 8 of 5 of spades, whereas my computer has picked up a queen and a 9. Very clearly we can see that the sum of these two is higher in case of the a computer, and hence the computer wins. But let's just convince ourselves. So I say PC toss. Well, that list is indeed S8 and S5. So spade 8 of spades and 8 of 5 of spades. Once I find the sum of these, so basically I say, well, look, PC toss say 0, so I look at the, so PC toss 0 1, this must be an 8, like a character 8. I will say, well, cards dot index PC toss 0, so that will be the sort of value of it starting from 0, and remember the first character is actually 2. Now when I do this, I say cards dot index, let's say PC toss say 1 and 1. Now second one is always to be 1, first one is the second item, so that becomes 9. Now if I were to run the same metric on my computer cards, I get, let's say 17. So clearly computer has won. In fact, we could see it from there. Like I said, now there is a version of war, where this same idea is applied, for example, in the gameplay itself. So people pick 2 cards each, and whoever has a bigger sum, ignoring the suit, is considered the winner. In fact, when it comes to picking up multiple cards, well, there are many situations, many possibilities that come up. For example, I could argue that the player who draws 2 cards from the same suit wins the toss. In case both the players do so, which means both of them pick up from the same suit, then the larger suit wins. Now this is interesting. Here we are kind of ignoring the number but focusing more on the suit, but not of just one card but both the cards. So for instance, let's say player 1 draws say C2 and C8, so 2 of clubs and 8 of clubs. Player 2 draws, for example, ace of spade and king of diamonds, really good cards in usual gameplay. But here, we say player 1 wins because these two come from the same suit. On the other hand, let's say player 1 draws C2 and C8, and player 2 draws say H2 and H3. We will say, well, player 2 wins because, larger suits, because heart is considered bigger than, let's say, clubs. On the other hand, let's say take one more example. Let's say player 1 draws C2 and C8, player 2 draws C5 and CQ. In our case, we say, well, look, these are equal suits, so, we will just say it's a tie. We will redo the toss. But of course, you can put a different rule and you can say that, look, in this case, I'm going to look at the sum of the 2 cards. So that way, you'll combine both the suits and the number, but I'm just keeping it simple. However, let's try to just build this for now. In fact, as it turns out, this is fairly involved because multiple scenarios come up. For example, I ask myself, well, is the player cards the same suit and the computer cards the same suit? If that is true, I just compare the suit, and in this case, whoever is the bigger suit wins. If both of them have the same suit, which is player card same as a computer's card suit, then I say, well, I just redo the toss. Next, I look at situation where player card has the same suit but computer card is not. Player wins. Reverse, computer wins. And if both are not from the same suit, which means neither has the same suit, then I just say redo toss. Now, in order to implement this in code, again, this looks complicated, but it's quite logical. I just compare the suit of, let's say, the player cards, the 2 player cards, if both of them are equal, and I compare the suits of the 2 computer cards. So if both of these are also equal, then I'm in the first scenario. I look at which is a bigger suit. So if both of these, if computer, player is a bigger suit, player wins. Computer is the bigger suit, computer wins. I think this is a typo here, so this should have been reversed. So if computer is a bigger suit, then computer wins. Otherwise, there's a tie. The toss will be redone. On the other hand, let's say player is from the same suit, computer cards are not from the same suit. In this case, player wins. And reverse, if player is not from the same suit, computer is from the same suit, then computer wins. So let's just kind of see this in code and get some intuition around it. So again, these conditions are getting quite complicated, but anyway, previously we have picked up 2, so I'm going to just say ignore this for now. You have to be a little bit careful over here. So I'm just going to say, look, so I asked myself a question. Well, if say PC toss say 0, 0. Now this is, remember, my, so I'm going to ask myself, well, I'm going to ask myself if say PC toss say 0, 0, which is the suit of the first card of the PC. player cards is equal to PC toss. Well, I look at the one, the second card, and the next element has to be 0 because we are looking at the first character of that. If this, that means player suit are from the same, if player cards are from the same suit, and let's say the other condition, which is exactly this condition but for the CC toss. So I say, well, if, and let's say CC toss 0 is equal to, say, so computer cards are also from the same suit. If this happens, so I just say both same suit. Now in this case I must figure out which of these is the larger suit. So I do that by saying, well, if, say, suits dot index, I can just look at any of these. PC toss, let's say 0, 0, 0 is, let's say, greater than suits dot index CC toss 0, 0. So if this is the case, in that case, well, I know that the player has won. So I just put, for example, player 1, and done is true because indeed the toss is done. On the other hand, if the reverse of this happens, which means, so I take this whole thing and I just say, well, here, if the reverse were to happen, notice it means that the reverse situation means that the computer suit is actually bigger than the player suit. So I put a reverse here. I say, well, computer wins. Now this was a situation when both were the same suit. Now, having done this, in fact, I can create other situations. So I just say elif. Okay, the indentation is extremely important over here. Okay, so elif, my condition is, well, look, player cards are not from the same suit, but let's say the computer cards are from the same suit. So if that is the case, well, in that case computer is winning this because computer cards are from the same suit. So I just say this, let's say, and finally the last condition. So I'm just going to copy this. Now be very careful while copying and pasting because indentation sometimes goes off. We have to be a little bit careful. Like now this elif is at the same level. So again, I'll unindent these so that this remains correct, right? So okay, let's see. So notice here, this is, first I ask myself if both of them are from the same suit. If not, then I come into this, I check if computers are from the same suit. Next I come out and I say, well, if these player cards are from the same suit, computer card is not, then in that case, well, indeed player has won. So we are a little bit complicated but quite nice. And again, having done all this, I don't really need this anymore. So this is it, right? So I need this code. Now be very careful with the indentations, and that's really all we need. Let's see this working. Now when I ran this code, it was interesting. First time round I picked up ace, and let's say ace of diamond, and say 10 of spade for the player. For the computer I picked up 9 of clubs and say ace of spade for the computer. Neither of these were in the same suit, so I just decided to redo the toss. Next time I saw, okay, look, player is winning this because player has picked up C, Q, and CA, which means queen of clubs and ace of clubs, whereas the computer has picked up H and C, which is one heart and one club. So clearly the player has won the toss. Now you can see this has become quite interesting. Like I said, right, you can in fact build this game, build these ideas in the gameplay itself, making the gameplay that much more interesting and giving you what are kind of very well known variants of war. For example, there is something called addition war where we actually add the two cards just like we did earlier. Now this could be another of those variants. In fact, we can extend this idea further and we can say that, look, instead of 2 cards, I'm going to pick 3 cards, and that brings up a lot of possibilities. We can refer to some very popular card games which have this hierarchy. They follow the trail, which is 3 cards of same value is given higher weightage than, let's say, a sequence, which is given a higher weightage than, let's say, a sequence where I ignore the suit, the color, and so on. We are going to look at some of this as we build the gameplay. You can see that those ideas can be applied to the toss, also to the gameplay. Now, really, I want to be very clear here. We are not encouraging or condoning gambling over here, but all we are interested in is the logic, and that is really beautiful, how these cards are analyzed, how these sequences are analyzed. and there's a lot to learn from these examples. So that's what we are going to go. But once we get to the to the gameplay itself, clearly you can see that ideas that are being used for the toss can be applied to the gameplay and vice versa. I hope you found this interesting. In general, if you think this way of learning works for you, where we build activities, we think about enhancing them, we write code to enhance our understanding, look at our website, because that is how we learn Python programming. Take care. Thank you so much. Bye bye.